So I had a request to do a video for graphing piecewise functions. This is important for us as we talk about both limits and continuity. So most of the piecewise functions that I give you in class aren't going to be super difficult. I'm trying to make sure that you can graph or understand continuity more so than graphing piecewise functions, but you definitely should understand what these different functions look like and how to graph them. So first thing is actually reading what this says. I found that sometimes students don't actually know what this means. Right? So it's basically saying that we have four different functions. F of x is equal to 2x plus 1. F of x is equal to x minus 1 squared. F of x is equal to 4. And f of x is equal to negative x plus 5. But, and then here's the important part, the domain, the listed domain is going to be this part right here. So this tells us the domain that each of these little branches, right, these things are branches, of the function exists on. So the first function exists whenever x is negative 2 or less. So it exists over here. The second function exists between negative 2 and 1. So that's where the second function is going to live. The third function is going to live between 1 and 3. And the fourth function is going to live from 5 off to infinity. Right, so if all we need to do is find the domain, well, we could look at like this x-axis, the number line, to figure out that the domain is going to be negative infinity. It goes all the way up. Whoosh, oh, that was not even close to a straight line. All the way up to 3, but it doesn't equal 3. But then it also exists from 5 all the way up to infinity. So it can equal 5, so hard bracket, and then infinity. Right, so this would be the domain of the function. All right, but I'm not going to ask you, hey, what's the domain? I'm going to ask you to graph because we need to figure out where there's jumps or breaks or gaps or whatever there might be. So let's actually graph these things on these separate pieces. One second, I'm just going to clean everything up. All right, so to graph a piecewise function, there's a lot of ways to do them, but I think the best way is to kind of like follow these kind of guidelines. So the first thing that you want to do is evaluate the function at an endpoint if possible. You can't evaluate it at infinity or anything like that, but just understand like what happens as it goes off towards infinity, that end behavior. So if I look at this first function, f of x equals 2x plus 1. So we want to evaluate it at the endpoint at negative 2. So f of negative 2 would equal 2 times negative 2 plus 1, which is going to give us negative 3. So this lets us know that the point 2, negative 3, is on the function, or that's what it's approaching. Now, because we have a less than or equal to sign, it means that this point, negative 2, negative 3, is actually on the function. So we would graph that with a closed circle. Then, using our knowledge of functions, 2x plus 1 is linear. So it's a linear function. The slope of it is 2. So from negative infinity all the way up to negative 2, the slope of it is going to be 2. Right, so it would look something like this. Right, so that would be our function. This is 2x plus 1. So then the next part of the function is x minus 1 squared, or f of x equals. So we want to evaluate at the endpoints negative 2. F of negative 2 would be negative 2 minus 1 squared, which is 9. So negative 2, negative 9 would be the point. But because we just have a less than sign and not a less than or equal to, we don't actually have negative 2, negative 9 on the function, but we get really, really close to it. We show that with an open circle. So negative 2, negative 9 has an open circle. And then if we evaluate f of 1, we're going to get 1 minus 1 squared, or 0. So 1, 0. Again, we don't have a less than or equal to, we just have a less than. So 1, 0 would be an open circle. Now, here's what I mean by using like our knowledge of functions to graph. Right? You could graph things like f of negative 1, f of 0, see what point you get and kind of graph that way. But x minus 1 squared is a quadratic, right? So we know that it's a parabola. So normally a parabola would look like this, but if we have x minus 1, this would be x squared. X minus 1, we've shifted this function to the right 1 units. But that was the whole function transformations thing. So it's going to look like this. So what that means for us is that between this -2, it has to kind of slope downwards until it hits that 0 point. So it's going to look like this, more or less. Not trying to scale. I don't care if you draw these pictures to scale. They just, should be pretty close. We'll just use them for general pictures. So you have kind of like half of a parabola between those 2 points. So I'm going to do some cleaning up again. So when we look at the third function is the easiest one. You love when you get kind of like constants on the domain. So for the third function, it's just f of x is equal to 4. Oh, still in the erase mode. So f of x is equal to 4. So when we evaluate it at this endpoint, f of 1 is 4. So 1, 4 is on because we have less than or equal to. And f of 3 is also equal to 4. So 3, 4 is also, not on the endpoint. Right, so we're going to have a closed circle and an open circle here. At 1, 4, we have a closed circle. At 3, 4, we have an open circle. And using our knowledge of functions, it's a constant. So it's just a straight line between those two. So this is f of x equals 4. This branch here was f of x was x minus 1 squared. And then finally the last function. Right, so we have, what am I going to do up here? So we have f of x is equal to negative x plus 5. Evaluating it at the endpoint of 5, f of 5 would be negative 5 plus 5, or 0. So 5, 0 is the point, and it can equal 5, 0 because we have a less than or equal to. So you have a closed circle at 5. Things we know, it's a linear function. The slope of it is -1, so it's going to go down 1, right 1, down 1, right 1, from there to infinity. Right, so this is what the function, the piecewise function, looks like. I'll try to get some more different examples up as well, but this is kind of like the idea behind these piecewise function graphings. You just have a function that you are literally graphing in pieces on the required domain and seeing what ends up happening. All right, so hope that helps.